Hello, so we're back for section 4.2. Now, we did 4.1 and we talked about correlation and causation. We found out what the R value was and what it meant to have an R value, how to interpret the R value, when can we use the R value. For a recap, we can only use the R value when we are working with a linear correlation, a linear relationship. No other relationship can we use the R value for. So we're going to move to section 4.2, which is the least square regression line. So as we talked before, we talked about this line that doesn't necessarily touch all the points, but it's the best line that fits it. And that's what we call the least square regression line. All right, so I'm going to share my screen again and get my PowerPoint set up in a second. Okay, so let's get started. So the least square regression line in 4.2, that's what we're going to talk about. So when we finish this lesson, you'll be able to compute the least square regression line in your calculator. You'll be able to use the least square regression line to make predictions about other things, and then you'll be able to interpret predicted values, the slope, the y-intercept of the least regression line. So look forward to being able to do that at the end of this PowerPoint lecture. All right. So computing the least square regression line. Now remember on the last in 4.1, we talked about house size versus the sales price, and we came up with, or they came up with, this scattered plot here. We used eggs and milk, which we'll use again, and they came up with this scattered plot here. So we see that it's a linear relationship. We can draw a line, all right, a line right here, approximately right here, to indicate we see that there's a positive linear relationship. We concluded that it was a strong positive linear relationship, okay? So here is that line I was telling you about between those prices. So if you were to take and draw a line, right, for those sizes and the prices, this line would be the closest to approximating the rest of those lines. As you see, we can look at the vertical distance to the line from each point, there, and see, you know, where those points lie in reference to that line. So it is clear that the line in the figure on the left fits better than the line in the figure on the right. If you look at that line. See how far these numbers are away from that line. Doesn't mean it's not linear. It just means it's it's a closer fit. So the reason is that the vertical distance are on the whole smaller. All right. So those vertical distances are smaller. All right. And the line that fits the best is the line for which the sum of the square vertical distances is as small as possible. All right, that's what the least square regression line is this line that we make, all right, that approximates this data, this linear line that we make that approximates this data, and that it's as small as possible. The distance from all of the points to the line is as small as they can possibly be, okay? So let's take a look, all right? So this is the least square regression line, all right? So it's actually y right here, all right? That's the least square regression line with the y hat, right? That's a little hat on top. Y hat equals b sub o plus b1 x. Now this is similar to y equals mx plus b. It's actually written the other way. But since it's for linear regression, we have a different set of letters to indicate basically the same thing, the slope and the intercept. All right, but this is y hat equals bo plus b1x, all right, where we know the slope is in front of x, if you remember your algebra, which is b1, and the y-intercept is off by itself, which is bo. Here they rearranged it to give it to you in a different form, but just know y equals b sub o plus b sub 1x, all right, and we'll have that as y equals a plus bx in a minute, okay? So the variables we want to predict, all right, the variable we want to predict in this case is selling price, all right? That is called the outcome variable or the response variable, all right? So we want to predict selling price based on the sizes of this house. And then the variable we are given is called the explanatory variable or the predictor variable. So we are given the square feet and we want to predict how much money that house will cost us, all right? So X represents the explanatory variable and Y is the outcome variable. Think about that in your normal algebra concept, the concept you have in algebra. You have Y equals mx plus b. You plug in an X, you would get out a Y. Same difference here, all right? X represents the explanatory variable and Y represents the outcome variable. Make sure you know that. That sounds like a good multiple guess question, all right? So here it says, compute the least square regression line for this predicted selling price for the size. Again, this is going to be something that we do in our calculator, so you're not going to have to do all this stuff by hand, but ultimately this is the line that they have with all of these extra numbers. 160.1939 plus 0.0992x. And I'll show you how to do that in your calculator, all right? This is the screen that goes through how to do it in your calculator. Remember, we already turned diagnostic on, so we don't have to turn it on again, okay? We turned it on in the last ones. All right, and then they show you how to go through and get it, which I'll do an example, probably do the example again, okay? So yeah, the next objective is to use the least square regression line to make predictions. Now we want to make our predictions. After we get this least square regression line in our calculator, or we get it written down, now we want to make predictions about it, okay? So we got this prediction, y hat is equal to this stuff. That was our line. So now what they're asking us to do is predict the selling price of a house of size 2,800 square feet. Well, we want to predict this price of this 2,800 square feet, this right here. So we take 2,800, put it in for X, and then we'll get out our Y, which we will definitely go over in our example. So when you put 2,800 in here and you work it out, you'll get a Y of about 438.0. Okay, so you could pop that in your calculator and see. Again, I'll do an example in a few. All right. Our next objective that we talked about is now we want to interpret the predicted values, the slope, the y-intercept, and all that stuff for this least square regression line. So we said the predicted value, which is that y hat, can be used to estimate the average outcome for a given value of x, right? We use that to get that outcome. For any x, the value y hat is an estimate of the average y values for all points with that x. Makes sense. Whatever x we put in, we're going to get out that y hat. So use the equation of the least square regression line for predicting selling price from size, that equation to estimate the average price of all houses whose size is 3,000 square feet. So we still put 3,000 into this equation. So we're trying to see if your house is 3,000 square feet, no matter where you are, if we're using this least square regression line, what will be the average price of your house? So when you plug that in, it looks like it'll be $457.8 thousand. So we estimate an average price for a house that's 3,000 square feet to be $457.8 thousand. So the question is, when I ask you to interpret it, that's going to be given back to me in the sentence. Let's repeat that. When you're asked to interpret, that means give me back an answer in a sentence. So you can't just put the equation in and then write down that answer. The interpretation are words. We interpret something by stating it in words. So your words would be the estimate. We estimate the average price for a house of 3,000 square feet to be $457.8 thousand. That's the interpretation. If you just put the number in, you just plug it in a calculator and write down that number, you'll get it wrong if it's asking you to interpret it, okay? The interpretation means words. Just a solution is a mathematical answer with numbers, all right? So here, interpreting our y-intercepts, okay? So we know the y-intercept, or BO as we may call it here. The y-intercept is the point where the line crosses the y-axis. And so this might be something that you have to pull up and recall from algebra. But the y-intercept is where the line crosses your y-axis. So if you have this line right here, right? All right, where does it cross the y-axis? That's your intercept, where it crosses the y-axis. Remember, this is the x and this is the y. So where does it cross the y-axis? All right. So this has a practical interpretation only when the data contains both positive and negative values of x. All right. So if the data contains both positive and negative values of x, then the y-intercept is the estimated outcome when the value of the explanatory value x is 0. All right. Okay, let's rewind to some algebra concepts. The y-intercept is when x is 0. That's what the y-intercept is. It doesn't change. So the y-intercept is when x is 0. So that's what they're saying here. But if the x values are all positive or all negative, then the y-intercept does not have a useful interpretation, because we know that the y-intercept is talking about when x is 0. All right. So let me explain that a little bit better using this example. It says, okay, it says, if the x values of 2 points on a line differ by 1, their y values would differ by an amount equal to the slope of the line. This is interpretation of the slope. So up 1 and over whatever, all right? This fact enables us to interpret the slope of the least square regression line. If the values of the explanatory variable for 2 individuals differ by 1, their predicted values will differ by B1. All right, all this stuff, I'm not going to read that whole thing because you don't understand what the hell I'm talking about. Sounds like Charlie Brown teachers. So let's go to an example so I can explain it better. All right, so 2 houses are up for sale. One house is 1,900 square feet in size, and the other house is 1,750 square feet in size. So we want to know by how much should we predict their prices to differ. How much are we going to predict these prices to differ? All right. And they're going to differ by the amount of square footage, right? Because we know square footage, each square foot would add on so much more money. So by how much should we predict their prices to differ? So the first thing we got to do is figure out the difference between the square footage of each home, right? So take the 1,900 minus 1,750, all right? So once we do that, we'll get 150, right? So then, right, the slope of the least square regression line was 0.0992. That was from the other example. So we predict the prices to differ by $14,900, $14,900. How did they get that? Well, we knew that the slope, that the B was, it was BX. I can go back to 0.0992. And then we multiply that by the change. See, remember that equation? See, right here? In that equation, it was 0.0992x. So it's going to differ by this. So that's where they got 0.0992, and the x was the difference. Okay? So 14.9. So that's the end. I'm going to give you an example because I know the last part got a little intricate and interesting. So you should know the definition of the outcome or the response variables and explanatory and predictor variables. All right, that'll be a multiple choice question. Which one is which? All right, remember, X is the predictor, Y is the outcome. Okay. How to compute the least square regression line, we'll do that in our calculator. How to use the least square regression line to make predictions, plugging it in and getting out our prediction, and then ultimately how to interpret those 3 things. Okay. So let's take a look at this. Let's go back to our calculator and pull up an example. All right. So we're in section 4.2. All right. I'm going to use the egg example again. I don't know if the numbers are the same. I'm going to check it now. But this is 21 in section 4.2. So let's see. You go to Stat, Edit. Yeah, it looks like they're the same numbers. So since we have the same numbers, so we're going to say that we put in the numbers. All right. So we put in the numbers. We go back out. We go exactly where we were. We go to Stat. We go over to Calc. And then you use number 8, y equals a plus bx. Remember, it was bo plus b1x. Y equals a plus bx. Use that one. That's number 8. So I'm going to click on number 8. Okay, ready? All right, got to click on number 8. And then we said this stuff was already, it's the same number that we did before. All right, so we see the R value down there, which was the same. So the question is, compute the least square regression line for the predicting the price of milk from the price of eggs. So we're going to keep it 3 decimal places. After that, we're not going to write all those numbers down. So I'm going to go right here. Okay, so when I looked at the calculator, I can't never. It's going to be y equals a 2.759 plus b, which is 0.399x. Okay, so we're going to keep it to 3 decimal places. So let's write that down. So when they ask you for number 1, compute the least square regression line for predicting that, it's going to be y equals, let's say, 2.759 plus 0.3991, 0.399x. Oops. Okay. Oops. Why I keep doing it? All right. So let's underline it. All right. Because my line is jacked. All right. So anyway, that is the least square regression line. Okay. So the next question, yeah, so it's already up there. So the next question in this one says, this is 21, sorry if you didn't realize, on page 179 in section 4.2, it's our same eggs information. B says, if the price of eggs differ by 25 cents from 1 month to the next, by how much would you expect the price of milk to differ? All right, so if the price of eggs differed, how much would you expect the price of milk to differ? So you have to look when you put it in the calculator. All right, just so we remember, X was eggs, right? Eggs. And Y was milk. All right, so the question is saying, if we know eggs differ by 0.25, then what's Y? All right, so then we just take our equation because we're predicting 2.759, right, plus 0.399 times 0.25. Pop that in our calculator. And that should be Y hat, sorry about that. And figure out what we're going to get. So let's see. All right. So I'm just going to pop that into my equation. All right. Which is Wait a minute, I put that in there wrong. Need to use my glasses. All right, so X was that's my bad. I didn't write it right. Let's go back because we're doing a predictive value. Let's go back. Where is it? Sorry, hit that in there wrong. Okay, so what this is, I said 0.25. I needed to put on my glasses. I read the question wrong. So let's back this up a little. All right, so X wasn't eggs. X was the average price in dollars of a dozen eggs. So let's write that right. All right, and this was a gallon of milk. All right. Okay. That's what that was. So now we can take a look at it. Okay, so anyway, I just wrote this down. So the question is, I put on my glasses this time, if the price of eggs differ by 0.25 from 1 month to the next. So we're talking about differing. We're talking about increase from 1 month to the next. By how much would you expect the price of milk to differ? All right, that's talking about a slope. All right, because it is saying for every month, how do you expect the milk to differ if it's 0.25 for eggs? Well, you make that into a fraction. That's 0.25 eggs per 1, okay, per 0.1 milk, right? Okay, so for every time the eggs move up 0.25, you would expect the difference between milk to be 0.1, all right? So for each increase in egg, for every 0.25 egg, you get 0.10 in milk. So the answer to B is 0.10. We'll do another one. C, it says predict the price of milk in a month when the price of egg is 1.95. So they're telling you that the price of eggs, right? See, I should have wrote this neater. That the price of eggs is 1.95. They want to know how much is milk. Well, this equation tells us, right? Because this is the price of eggs with the price of milk. So now you got y hat is equal to 2.759 plus 0.399 times your milk, remember. Right? Times your eggs, which is X, to predict your milk, not times your milk. All right, so let's see how much the milk will be, all right, if the eggs are 1.95. So what we say that was 2. Okay, so we expect the milk to be how much? $3.54. All right. So all right, so that's how much your milk should be. That's the price of your milk when your eggs are $1.95. Okay, does that work? Let's try another one real quick. No, what I'll do is I'll wait. If you want me to try another one for you, you can let me know. And I will put another problem up, but this video is definitely long enough. So with that being the case, we'll work on it later. For any examples that you want me to do, we'll do it later so that this video can be over. All right. So that takes care of section 4.2 because we still have to do 4.3. So now you know how to go in the calculator, you know how to predict the value, you know how to find the least square regression line, which is important. You know how to find the R value, you know how to interpret the R value, you know how to do all of those things. So I will see you in the next video, which is section 4.3, which finishes up this information. Thank you, and if you need any help, just let me know.